This is a demonstration of running a hypothesis test for the difference between proportions. I'm going to jump right into this and let you know that I am going to be using the phantoms method of running this hypothesis test. If you don't know what that is, watch some of my previous videos. Some of my older ones explain what phantoms is. So I'm going to go pretty fast here. Here's the question. It says, in a study of 200 randomly selected adult female and 250 randomly selected adult male internet users, 30% of the females and 38% of the males said that they plan to shop online at least once during the next month. At alpha equals 0.1, test the claim that there is a difference. I'm going to highlight this right here. There is a difference between the proportion of female and the proportion of male internet users who plan to shop online. So let's just jump right into phantoms. P stands for my parameter statement. This basically sets up what I am going to test. What is the claim? So this is how I wrote it. I will test the claim that there is a difference between the proportion of female and male internet users who plan to shop online. So that's what I'm going to test. With that said, I now need to set up my null and alternative hypothesis. Well, I'm saying basically that the proportion of females is not equal to the proportion for males. That's the claim that I'm looking at when I say that there is a difference. I highlighted that up here. So knowing that, I'm going to set up my alternative hypothesis this way. The proportion of females minus the proportion of males is not equal to 0. Because if I take the proportion of females minus or is not equal to the proportion of males, if I set this equal to 0, I would go minus the proportion of males on both sides. And that gives me what I've got right here. Okay? So that's where this alternative hypothesis comes from. Well, if this is my alternative hypothesis, and basically that is the claim that I am hoping to test, my null hypothesis has to be the proportion of females minus the proportion of males is equal to 0. In other words, there is no difference. Okay, so my null hypothesis is saying that there is no difference, but my alternative says that there is a difference, and that is actually the claim that I am testing. All right, let's continue. The next thing that I need to put down here is, this should not be a P, this should be an A, and this A stands for assumptions and conditions. So the first condition we need to check is randomization, and the internet users were selected at random. The second one is independence, and I am checking to see if the two samples are independent. Not that the females are independent of each other or the males are independent of each other, but the samples are independent, and they are. The last one that I need to check is the success failure, and I need to check N times P for the females, make sure that that's greater than 10, N times P for the males, make sure that that's greater than 10. I also need to check N times Q, make sure that for the females, and N times Q for the males. As long as every single one of those is greater than 10, then I'm okay, and that condition is satisfied as well. Trust me, all of these are satisfied. I'm not going to take the time to do the math that I think that you should be able to do on your own. Now I get to name the test. This is going to be a 2-sample z-test. The reason it is a z-test is because I'm working with proportions. And whenever you're working with proportions, it's a z-test. And I also want to make note that this is a 2-tailed test with alpha equals 0.1. The reason I know it's a 2-tailed test is because up here in my null and alternative hypothesis, this says equal and this says not equal to. So that makes it a 2-tailed test. All right. In order to find the test statistic, I could use this big, ugly formula. But we live in a day and age where there is technology that will do some things for us. I'm hoping, I know that if you've got me in class, I'm going to let you use your calculator to find the test statistic and then in turn the p-value. So this formula is where the test statistic comes from. But I'm going to set this off to the side. I'm actually not going to use that. I am going to use my calculator to find the test stat and the p-value. So let me pull my calculator up. And I'm going to go to stat, then arrow over to go over to tests. And before I said that this is a 2-sample or a 2-proportion z-test. So here number 6 is what I want, a 2-proportion z-test. Now it asks me for the x sub 1, n sub 1, x sub 2, n sub 2. Now if we go back, my original question does not give me well, let me put it this way. It does give me the sample size for the females and the sample size for the males, but it does not give me the actual number of males and the number of females that were out of the 200 or out of the 250. It just tells me 30%. It is 30% of the females and 38% of the males. So in order to find, go back to my calculator, in order to find x sub 1, I'm going to let the 1 be the females, x sub 1 for the females and x sub 2 for the males. Basically what I have to do is take 30% of 200 to get the x sub 1 for the females and 38% of 250 to get the x sub 1 for the males. I've done that ahead of time and I've found those values. So if you need some help with that, just, it's just multiplication. You should be able to multiply. So what I found was that 60 out of the 200 females will shop online. So there's that proportion. And then 95 out of the 250 males will shop online. So I have to tell the calculator this is the data that I want you to use, x sub 1 and n sub 1 for the females, x sub 2, n sub 2 for the males. And this is a two-tailed test, and my alternative hypothesis has the symbol not equal to. So I need to highlight this and make sure that is selected. Then I can go to calculate, and the calculator finds the test statistic and also finds the p-value for me. So let me grab this and bring this down to where I can label it. I'll make it a little bit bigger here. But here it is. This z is my test statistic, and this p right below it is my p-value. So I now know that my test statistic z is equal to about negative 1.77, and I know that my p-value is equal to 0.075. Well, at this point, if you're watching this video, you probably know what to do with the p-value and how the p-value and the test statistic are related. If you don't know that, watch some of my old videos and you'll be able to pick that out, or check with your teacher. But anyways, what do I do now? Well, since the p-value is less than alpha, I reject the null hypothesis. The p-value is the probability that the results that I got just happened by chance. And in this case, I'm comparing that to alpha, which was equal to 0.1 or 10%. So if I get a p-value that's less than 10%, I'm going to reject the null hypothesis. And that's what I did right here. Now, since I am rejecting the null hypothesis, let's go back up to the top. Since I am rejecting the null hypothesis, I'm not okay with the null. That means that I am okay with the alternative, and that means my evidence does support the claim. So at the very end, as I write my final conclusion, since I'm rejecting the null, I'm going to support the claim, and it says this: there is enough evidence to support the claim that there is a difference between the proportion of female and the proportion of males that will shop online. So there's an example of how you can conduct a hypothesis test for the difference between proportions. I hope this helps, and have fun in your stats class.